I'm your host, Jean-Georges Perrin, or JG, and this is the 13th episode of Data Friday. Already 13th. Yeah, it's kind of the magic number. So today we are continuing our journey on Spark, and you can see that we run out of example of chapter 3, so it's about time to go to chapter 4. Okay, so chapter 4 of Spark in Action, second edition. So we are going to roughly go through an adapted version of Lab 200, and I'll show you what it does first, and then we will try to understand a little bit what's going on. Okay, so let's cut the chase and really run it right away. Okay, so run as my Lab 200 Java app. Time for a little bit of a sip of tea. So look closely where the time is being spent here, and we're going to look more closely at the code right now. Okay, so basically creating a session, loading the initial data set about 6 seconds, building the full data set, and I'll explain that. A little bit of cleanup, transformations, heavy transformations, and then the final action there. Okay, all that we're processing about less than 500,000 records. Okay, so let's look at the code. Okay, so my imports, nothing fancy here. Dataset, row, Spark session. I'm also using a static functions, the exp static function, which I really like to call a bit like the Swiss Army knife, because you can do a lot of things with it really easily. It's almost like SQL applied to it. Okay, so main, I'm starting in a mode called full. The different modes are explained in the book, but the full is actually what it's supposed to do a lot more work. Starting, and I start my timer. First thing is I start my session. I create my session. Okay, nothing original there, and that's where you see it here. It's actually taking about 3 seconds. Then I am reading CSV files. It's not a huge file. It's containing the birth rates for teens in the US, described by county. The file itself is about 45. It's about 45,000 records, so it's not a huge file. And you see that it takes in about, on my moderately slow Mac, about 6 seconds. And then I'm creating, yeah, that's where I'm creating my data frame. You'll see why I'm doing this trick there, and that's it. Okay, so now I'm building a bigger data set. My bigger data set is because I just wanted to do some work. Okay, so I'm basically unioning itself on itself for 10 times, and that is actually taking something like 269 milliseconds. Okay, so this is where you should start thinking about something is weird there. Okay, like 45,000 records. Okay, it took about 6 seconds to load, but to recreate almost 400,000 records, or about 400,000 records on itself, it only takes 269 milliseconds. Yeah, that sounds yeah, it sounds low, no, right? Then I'm just doing a little bit of cleanup, like just renaming columns, so let's forget about that. It's only taking 26 milliseconds anyway. And then the step 5 is about the transformation itself. Okay, so that's where you've got the different modes. But if basically here I am going to the full mode, so basically what I'm doing is creating an average of the LCL and UCL columns. I'm also duplicating the columns. Okay, and after that I'm actually dropping the average and the LCL columns and the UCL column. Okay, so if you do that, okay, if you do that on normal kind of relational database and you're doing this kind of, or in an application, you can actually see that all what's being done here, okay, is being consoled here, okay. So that's why even if the transformation is taking only 560 milliseconds, the final action is roughly, let's take a note here, full, it's 5,759 millisecond in full mode, okay. So the same amount of record process. So now let's look at if I'm not going through full mode, but I'm just doing the first operation, that's the creation, okay, to see if it's faster or slower. Okay, creating a session, loading the file, transformation, and the final action is coming. Okay, final action is here. You see it, final action is for the normal process. It's 9,872 milliseconds. The transformation itself did not change, right? It's a very similar number to what we had before. Same thing for the other one. Some are just a little bit slower, but as the day goes, my machine is going slower as well. So like me, and so what happens there? Okay, there's a big difference between the two applications. Is one, we actually created the columns and deleted it. That was a full operation we just did before, and in this one, we just created it. So basically, by doing more, as we did in the first lab, in the first session of this lab, we spend less time. Okay, that's probably a little bit confusing, right? You do more things, but you're actually doing less. Okay, it actually takes less time. So let's try to forget about the code and look a little bit about what happens in the full process. Okay, so and I think it's good to represent that as a graph. So first operation in my graph is I am loading the data. Okay, then I am duplicating the data. Then after duplicating the data, I am going to do the cleanup. Let's ignore the cleanup, and I'm going to do some transformation. Okay. If I look at the transformation in details here, what I'm doing first is I'm actually doing an average. Then I'm doing duplicate column. Then another duplicate column. Then I'm dropping average, drop average, and then I'm dropping a column I created, and I'm dropping another column. Okay, and then I'm just collecting the result. Then basically it's collecting. Okay, so collect. That's a full process. The normal process we just run is, so the normal process, very similar. Load data, duplicate the records to have significant ones, and then we do some transformation as well. Okay, so what I'm doing here is average, duplicate, and I'm not dropping anything, I'm collecting. Okay, this is the normal process, more or less 10 seconds. The full process, more or less 6 seconds. Why? Well, when you actually do these things and you see actually the timing, okay, in the timing the transformation is really super fast itself, okay. So the transformation part here is this was more or less 600 milliseconds, okay, for both. So whatever operation I'm doing in the transformation part, it did not change, okay. It's really it's very similar. So what changed between the two is in my full process, I did some cleanup, okay. So and basically what you can see in my graph here is that, okay, I'm doing average, duplicate, and then I'm going to drop average, drop column, the duplicate, and the other duplicate, okay. So Spark sees that and says, hey, this is completely bullshit, okay. So this is, I don't need that. Okay, I really don't need it. So just get rid of it. Okay, so that's it. So basically, the full process is only about loading duplicated data, no transformation, and then collect, because the operation I do in the transformation are canceling itself. Okay, so Spark is smart enough to analyze this graph, and based on the analysis of this graph, realize and optimize its processing. Okay, so this graph is called directed acyclic graph. So it's not even a magic there. It's a graph you can go only in one way. You can't have loopbacks in it. The precious 3-letter acronym for that is DAG. Okay, so you will probably hear a lot about DAGs. And yeah, so Spark doesn't do anything until you call an action, okay? And when you call the action, that's where things starts to happen. And that's where your process that is actually transformed from your code into a graph is actually being used for the process, okay, on the optimization. This operation is done by the Spark internal optimizer, which is called Catalyst, and that's one of the very, very powerful features of Spark. Of course, this example was completely benign, but you will see in your scenarios that Catalyst works under the scene and corrects all these things. I hope this was useful to you, and that we'll meet next Friday for more DataFriday. And I know I've promised that for a long time, but next Friday is going to be really special, as I'm going to have a guest, and we're going to talk Spark, Kubernetes, and all that live with examples. Okay, so guys, have a fantastic week ahead of you, and I hope you enjoyed this episode. Bye, guys.